In this illustration, we intend to simulate the cyclic behavior of reduced beam section connection in the Abaqus software. In this problem, a cyclic loading will be applied to the end of the beam, and then the hysteresis diagram of the model will be drawn. In this picture, the hysteresis diagram having been obtained from the Abaqus software has been compared with the laboratory results. In this picture, you can observe the deformation of the model under the cyclic loading. In the first picture, the deformation obtained from the Abaqus software has been compared with the laboratory results. And as you observe, there is a good conformity between the results of the Abaqus software with the laboratory ones. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Promotion of Cyclic Behavior of Reduced Beam Section Connections, Restraining Beam Web to Local Buckling. In the next step, we intend to convert a common beam into RBS. I click on Create Cut Extrude, select this surface, then this line. Actually, you can observe the geometric shape of the beam having been cut. Draw an arc in this manner. The distance between these 2 points is equal to 100 millimeters. The distance between these 2 points is equal to 350 millimeters. The distance between these two is equal to 45 millimeters. In the next step, I'll click on Mirror, then on Copy. Select this line, then this arc, and done. In the next step, I'll complete the shape. Done. Here, click on Flip Direction and OK. First, here, I intend to define the properties of the beam. I will click on Mechanical menu, then select Elasticity and Elastic. Young modulus is equal to 200 gigapascal. I will enter that equal to 200,000 megapascal. And Poisson ratio is equal to 0.3. In the next step, I'll click on Mechanical menu, select Plasticity and Plastic. Here you observe deformation of the model in the laboratory. Here you can observe the deformation of the model in the Abaqus software. As you observe, the deformation obtained from the Abaqus software are really close to the results mentioned in the article. In fact, as it can be observed, the buckling has occurred in the beam. In the next step, we intend to draw the hysteresis diagram of the model. Actually, we intend to draw this diagram in the Abaqus software. The horizontal axis is rotation and the vertical axis is moment. I will click on Create XY Data, select ODB Field Output and continue. First here, I'll select Unique Nodal, then RF3. After that, I'll select U3. I will select Set 2, that concerns the place of loading. I will click on Create XY Data, select Operate on XY Data, continue. Here, I will select All Reaction Forces. Then select Sum. Click on Add to Expression and then on Save As. In this manner, all reaction forces will be added up together. In the next step, I select force and multiply that by 2.9 meters. Actually, 2.9 refers to the distance between the place of loading to the middle of the column. In the next step, I select U3 and divide that by 2,900 millimeters. In this way, we will obtain the quantity of rotation. Here first, I'll click on Combine. Then select Rotation. Then Moment, and finally click on Save As. Here you can observe the hysteresis diagram of the model. I will transfer this diagram to the Excel software. The first column is rotation, the unit of which is radian. The second column is moment, the unit of which is Newton meter. Here, the diagram having been drawn with red color is the one having been obtained from the Abaqus software. As you observe, the results obtained from the Abaqus software are close to the results mentioned in the article, indicating that the question has been simulated correctly in the Abaqus software.